Hello, this is Dr. Mears. Today we are going to be using the remainder theorem to find a remainder without doing long division. So it's magic because we don't have to do long division. How do you use the remainder theorem? First, we're going to set the binomial equal to 0 and solve. And then we're going to use some substitution into the polynomial and evaluate it. And then we're going to get an answer. That answer is our remainder. And so if their answer is 0, then there's no remainder, which means the binomial is a factor. We can divide it out without having a remainder. If the answer is not 0, then there is a remainder, and the binomial will not be a factor, meaning we'll get leftover piece after we do long division. What does this look like? Let's do some examples. Your directions are going to be the following. Determine if each binomial is a factor of the polynomial using the remainder theorem. Show or explain why. So we have to determine if this binomial is a factor of this polynomial. So this is a binomial because bi meaning two terms, 1, 2. This is a polynomial because we have many terms, poly meaning many. So let's first set the binomial equal to 0 and solve. So we have to take n minus 5, set it equal to 0, and then use our inverse operations to solve. Or if you know that it is going to be the opposite, that's fine. Just be careful because this might be 3n minus 5. So the surefire way not to mess up is just to have it equal 0 and solve. So we're going to have n equals 5. We now need to substitute that number into our polynomial. So the second thing we're going to do is we're going to substitute 5 in. And the best way to do this is when you see a variable, I would automatically set up parentheses. And my videos coming up, we're going to be setting up these parentheses. So when you see n to the fourth, instead of the n, I write my parentheses to the fourth. And so that's where I'm going to enter my number. Minus 2. I see another n, so that's another variable. So I put parentheses to the third power, and then I put my 5 in. I really like to substitute like this because if this is a negative, your exponents are going to matter, and that's going to mess up your signs if you're not putting it in parentheses. So please, please utilize parentheses. Okay, we have minus 20. Again, the variable n, so I'm going to set up parentheses squared, put my 5 in. Plus 24. I see my variable, put parentheses 5, and then plus 5. Okay, now I'm going to do this directly in the calculator. I am not going to do order of operations. I'm just going to bring up my calculator and I'm going to enter it. So I am going to, hopefully you can see it, I'm going to use my parentheses. So parentheses 5 to the fourth. Notice I am in the exponent spot. You can see it blinking here. Let me see if there we go. You have to press the over arrow button if you get stuck in the exponent spot. So just be careful of that. A lot of people, all of a sudden, you're just writing everything in the exponent spot. So just be careful. 2 times 5 to the third minus 20 times 5 squared plus 24 times 5 plus 5. And let's just check it. I'm just going to scroll back to the beginning. So we have 5 to the fourth. Yep. Here we go. Let me see that. Yep. Minus 2 times 5 cubed minus 20 times 5 squared plus 24 times 5 plus 5. I'm going to press enter and look what we get. We get 0. That's great. So the third one, when we substitute the 5 into the function, that's what this means. When we substitute 5 into the function, we get 0. And so if the answer is 0, here's number 4. If the answer is 0, there is no remainder. That actually means the remainder is 0. The remainder is 0. So we have nothing left over. And the binomial, this binomial, n minus 5, is a factor. So when we use long division, we're going to get another polynomial that is a factor of our original. And I'm actually going to show you that because it is magic. So we're saying that our remainder is 0. Here is our long division. So here's long division. So if we took n minus 5 and we went through the whole process of long division, look what our remainder comes out to be. Our remainder is 0, which means n minus 5 is a factor. So if we took n minus 5 and we multiplied it by n cubed plus 3n squared minus 5n minus 1, we're going to get back the original polynomial. What does that mean? That means if I took n minus 5 and multiplied it by n cubed plus 3n squared minus 5n minus 1, I'm going to get n to the fourth minus 2n cubed minus 20n squared plus 24n plus 5. That's what it means to be a factor. We can multiply these. We have no remainder, and it comes out back to our original. Okay, let's look. So it's pretty cool that we can find the remainder without having to do all this work. So I really feel like it is magic. Okay, so let's look at our second one. And to make this a quicker video, what I have done is I did the workout, and we're just going to go through the work. And if you want to pause, you can, or if you just want to watch all the way through so you can see it done in one quick motion, you can. So we have f of x equals negative 5x cubed minus 9x squared minus 3x minus 14. We have our binomial x plus 2. We want to see what the remainder is. And if it's 0, then that means that this is going to be a factor. If it's not, then that is not a factor. Okay, so what's the first step? The first step is to take our binomial x minus 2 and set it equal to 0 and find what x is. So x equals negative 2. Next step is to take that negative 2 and substitute it in here using parentheses. And this is what I mean by utilizing your parentheses. We have a negative 2, and if we're putting it in, if we're cubing it, this negative will also be cubed. So pretty please use your parentheses. If we square a negative, that negative is going to be squared. So just be careful. Anywhere you see that x, I automatically set parentheses up with the exponent on the outside, and I put that number that we're substituting right in. It will make it easier. And what you're going to do is you're just going to enter this side into the calculator. You're going to enter just that side, and you're going to push enter after you're all done, and you're going to see that you come out with negative 4. Oh, so we have a remainder. So this is definitely, we didn't come out with 0. We actually came out with negative 4, which means the remainder is negative 4. We're going to have some left over. That means x plus 2 is not a factor. It will not be able to be divided and get a remainder of 0 because we're going to have some left over. So let's look at what happens if we actually did the long division. So here's a long division all done out for you. When we do x squared and we're dividing it by our polynomial here, we see we get another polynomial, but what happens is we get a remainder of negative 4, which means that it's not a factor because we have some left over. We have negative 4 left over. And so this has been using the remainder theorem to find if there is a remainder. Our remainder tells us if it is or is not a factor. And it's like magic because we don't have to go through the whole long division process. It's one quick substitution. Just be careful that you're setting the binomial equal to 0, and this is the number that you're substituting in. Okay, I hope it helped. Thanks for watching.